Hi guys, welcome back from break. Today we're going to be learning about the number of solutions. Now what that means is that we're going to be looking at equations that might have just one solution. You've already met those. When you get to the end and it's x equals -4, that's one solution. -4 is the solution. But when you have equations that have variables on both sides, sometimes you can have equations that have no solutions. An example, let's see. Turn the pen on. One example might be x equals x plus 2. Is there any number in the world that x could be that would make this true? No, because no matter what number x is, this side's always going to be 2 more. So that's an example of an equation that has no solution. There's no value of x that will make this work. All right? If you tried to solve this, what you would do is try to get all your variables on one side, so you would subtract x from both sides, and you end up with 0 equals 2, which is false. All right? 0 does not equal 2. All right? So this is an example of an equation with no solution. And when we get one of these, we write the words no solution. Okay, we don't put x as 0 because 0 is a solution. All right, we write no solution. Now, I also said that there are equations that could have infinite solutions. Let's look at one of those also. What if I had t plus 2 equals t plus 2? What could t be? Well, t could be anything because that t and that t have to be the same number. So no matter what number we pick for t, we're going to add 2 to it, and this side and this side are always going to be equal. So it doesn't matter if t is 1, 2, 3, 4, 10, a zillion. This left side and the right side will always equal each other. So t can be any number it wants to be. Okay? That is an example of an equation with infinite solutions. And now equations with one solution are what you're used to seeing. If you have 2x equals 6, all right, well, you know that you divide both sides by 2 and you get x equals 3. That is a one solution equation. And those are the ones that you're mostly familiar with. This will be the first time that you're seeing ones that have infinite or no solutions. That's what this chapter is about. Okay, so here is Reveal's math gobbledygook. The solution to an equation, I'm not even going to read this to you because you know what, you're just zoning out. You're probably watching YouTube anyway. Basically, they're telling you the same thing I just told you. And here they're giving examples of a no solution, one solution. They're using multiple variables. It's just terrifying. Let's look at this in a more simple version, my version. A one solution equation. You'll know you have a one solution equation when you simplify it and you find that the variables are not the same on both sides. See, for example, on the left-hand side, we have a positive 3x. On the right-hand side, we have a negative 5x. If the variable terms do not match, it has one solution. It can be solved, all right? I can solve this. I want to get all my variables on one side, so I add 5x to both sides. That gives me 8x plus 4 equals -1. Subtract 4 from both sides. I get 8x equals -5. Divide both sides by 8. And I get x is -5/8. It's not a pretty answer, but it's a single solution. It has one solution. All right? You'll know you have a one solution equation if the variable on the left-hand side and the variable on the right-hand side do not match. Infinite solutions are also called an identity. An equation with infinite solutions will be called an identity. There's a little racket in the hallway. I think Mr. McNeil's kids are here today and they're running up and down the ramp. Okay. So infinite solutions are equations like this. Notice that the left-hand side and the right-hand side are identical, right? They match perfectly. The variable terms match and the constants match. In that case, x can be any number it wants because no matter what x is, on both sides, we're going to multiply it by 3 and add 2. And since x has to be the same number and everywhere it occurs, the left and the right side will always be the same no matter what you pick for x. All right? Now, sometimes they try to get tricky. Notice the second one here. This is also identical. Negative 4t here, negative 4t here, positive 1 here, positive 1 here. They don't have to be in the same order, all right? But they have to be mathematically equivalent, right? Down here, this is what Reveal's going to throw at you right away, is an equation that needs to be simplified before you can tell how many solutions it has. So on the left-hand side, what you would do here is you would combine these two x's together to give yourself 2x plus 2. And then you realize that this is, in fact, an identity because it's exactly the same on the left and the right. Okay? Finally, we will see equations that have no solutions. When we have an equation with no solution, what we will notice is that the variables on each side are the same, but the constants are not. Okay? That results in a not equal situation every time. Look at this first example. No matter what y is, on both sides you're going to multiply it by 7. But only on the left-hand side are you then going to subtract 2. No matter what you pick for y, the left side will always be 2 less than the right side. They're not going to equal each other. So this has no solution. If the variable terms are the same, but the constants, the other numbers, are not the same, it has no solution. It will always be uneven. Sometimes these are quite tricky, all right? Like, for example, this one. This has a negative 4x and a negative 4x. So the constants are the same, but the variable terms are the same, but are the constants the same? They're not. This is a negative 6. This is a positive 6. Okay, so you have to be very careful. You've got to be like Sherlock Holmes sometimes with these. These are not equal. On this side, you add 6 to negative 4x. On this side, you subtract 6 from negative 4x. These are never going to be equal, so there's no solution to that equation. Okay, so right off the bat, they're giving you equations like you had in the last section and asking you to simplify them first to find out how many solutions it has. Okay, so here we have 6 times x minus 3. Our first goal then is to get rid of the parentheses by distributing this 6 to both of these, which gives us 6x, and 6 times negative 3 is negative 18. Bring down the plus 10. On this side, 2 times 3x is 6x, and 2 times negative 4 is negative 8. On the left, we now need to combine like terms. We have a negative 18 combining with a positive 10, which gives us a negative 8. So we have 6 minus 8 on the left, and 6x minus 8 on the left, 6x minus 8 on the right. You don't need to keep going. You know how this ends. The left and the right side are identical. All right, this is called an identity. They went ahead and solved, and they got rid of the x's by subtracting 6x from both sides, and they got a true statement, negative 8 equals negative 8. So let's see, the equation negative 8 equals negative 8 is true. I don't know what you would put in that box. It is true, because any value can be. So the equation has infinitely many solutions. The left and the right-hand sides are exact matches. And then you can replace x with any value to verify that the solution will work. No matter what you pick, they're going to tell you to put in 4. You get 16 equals 16. You get a true statement. I say you stop when you get to this point where you can tell that the left and right sides are identical. You don't need to work any further than that. Okay, so this is a question you might encounter on a reveal test or your error test. Which equation has an infinite number of solutions? Remember, infinite means the left and the right sides are identical. The variable terms are the same and the constants are the same. So which of these is going to turn out that way? You got to do some work to find out. Let's get rid of the parentheses here. 2 times 3c is 6c, and 2 times negative 6 is negative 12. Minus 2c equals 4 times c is 4c, and 4 times positive 4 is positive 16. So on the left-hand side, we're going to combine 6c and negative 2c, which is going to give us 4c minus 12 equals 4c plus 16. Well, this is one of those cases where the variable terms are the same, but the constants are not. So no matter what value of c we pick, this will never work. This is one of those no solution ones. And it's not the answer to this question, because this question wants to know which equation has an infinite number of solutions. So A is not it. What about B? 3 times 2p is 6p. 3 times -1 is -3. 2 times p is 2p. 2 times 10 is 20. And then we have plus 1. So we have 6p minus 3 equals 2p plus 21. The variable terms are different. This equation has one solution. We will be able to solve for p. There is one number that will work here. All right, and if we wanted to keep going, we could find out what it is. But because the variable terms are different, it has one solution. We got to keep going. 8 times x is 8x. 8 times -9 is -72 equals 6 times 2x is 12x. And 6 times 12 is 72, -72, minus 4x, right? Well, the left-hand side is already simplified. 8x minus 72 equals 12x minus 4x is 8x minus 72. Winner, winner, chicken dinner. C is the correct answer because this is identical to this. It is an identity and it has infinite solutions, right? You want me to do D? We can see what kind of equation we get in D. We've already had no solution, one solution, and infinite solutions. I wonder what this one, we don't care. You don't want the video to be any longer than it has to be, right? Okay, so equations with no solution. Determine whether the equation has one solution, no solution, or infinitely many solutions. So that's what the directions will always say. So we distribute like we did before. 8 times 4 is 32. 8 times -2x is -16x. 4 times 3 is 12. 4 times -5x is -20x. Okay, and bring down the plus 4. On the left, there's nothing to simplify because these are not like terms. On the right, we bring down the 12, but we can combine a -20 with a +4 and get -16x. If you add 16x to both sides, I mean, even at this point, you could stop because you see that the variable terms are the same, but the constant terms are not. This left-hand side will always be 20 more than this one because 32 is 20 more than 12. All right? The x terms will always be the identical, but the left-hand side has 20 more units than the right-hand side. Okay? So down here, we would get that 32 equals 12, but it's not true because no values can be substituted to make the equation true. It has no solution. So that's if the variable terms match, but the other numbers don't. It creates an unequal equation. Okay, so again, they want to know which one of these has no solution. So here we go. We're looking for no solution means the variable terms match, but the constants do not. Okay, 5 times b is 5b. 5 times +3 is +15 minus 2b equals 2b plus 3. Okay. Let's combine like terms over here. 5b minus 2b is 3b plus 15 equals 2b plus 3. This equation has one solution. I know it has one solution because the variable terms do not match. If the variable terms match, it either has infinite solutions or no solutions. If they don't match, it's one solution. On letter B, 4 times d is 4d. 4 times -3 is -12. Plus 5, we just bring on down. 3 times d is 3d, and 3 times +2 is +6. Bring down the -7. So we could stop here because I can see that the variable terms aren't going to match. -12 and 5 is -7. There's only one 3D over here. 6 and negative 7 is minus 1. It doesn't matter what the constants are. If these are different, it has one solution. So, strike out number 2. We're looking for no solutions. Let's try this one. 3 times x is 3x. 3 times plus 5 is plus 15. 5 times x is 5x. And 5 times positive 3 is positive 15 minus 2x. Combining like terms, the left-hand side is already combined. On the right, we can combine 5x with negative 2x, which gives us 3x plus 15. These are identical. This has infinite solutions and is not the answer to this question. Now, I know some of you are going, well, you don't have to do D because we know D has to be the right answer because the first 3 weren't. Oh, I'm going to do D because I like doing math. Negative 10y, don't you dare fast forward me. Don't you dare, don't do it. Negative 3 times 5y is negative 15y. Negative 3 times negative 7 is positive 21 plus 5y. All right, on the left-hand side is already combined, so negative 10y plus 18. On the right-hand side, if I combine negative 15y with positive 5y, I get negative 10y. You saw that coming, right? Plus 21. This has no solution and is the answer to the question. We know it has no solution because the variable terms are identical. So that's always going to result in the same value. But on this side, we're adding 18 to the answer, and on this side, we're adding 21 to the answer. The right-hand side will always be 3 more than the left-hand side. There's no solution to this problem, and D is our answer. I know, I'm having a great time. I don't know about you guys. Okay, so analyze equations to determine the number of solutions. They're saying now that on page 162, they go, oh, it's possible to tell if they have no solutions, infinite solutions, or one solution without having to solve them all the way to the end. All right? So this is exactly what I've been telling you. No solution means the variable terms match, okay, but the constants are different. This is like your graphic organizers. The variable terms, and I'm going to put variable terms here because that's what I want you to think of. Nobody wants to think of coefficients. Okay, the variable terms are different in this one. And if the variable terms are different, it doesn't matter about the other numbers. This has one solution. That's the only kind of thing that can happen. If the variable terms on each side are different, it has one solution. That's it. If the variable terms are the same and the constants are the same, then they are identical and they are called an identity. And they have infinite solutions. Yep. So now they finally let you in on that little secret. All right, now here's where it gets fun. They want you to create an equation with infinitely many solutions. And I've seen these on the error test, so this is not outside the realm of possibility for you. They want you to create an equation that has infinite solutions, okay? Infinite solutions. And you know what? I haven't been telling you about these letters. These letters are to your secret word. Some of you may have caught on to those. Let's back up and get all these letters real quick because I forgot to say anything about those. Okay, write down an S. Write down a D. Write down N. Write down Y. Any letter in the little school bus, you write it down when we get to it, even if I forget to remind you. Okay, so we want to create an equation with infinite solutions. Infinite solutions means it has to be identical, it has to be same on that side as this side. The variable terms and the constants have to match, okay? But they've given us the left side is a gobbledygook, okay? So what we've got to do is get the left-hand side so that it's down to a variable term and a constant, okay? Well, let's combine like terms. This is a positive 6x, this is a negative 1x, and this is a positive 2x. What is 6 minus 1 plus 2? 7x. Okay, and then the plus 4 just gets brought down. So in order for this to be an identity, the right and left sides have to be identical. Therefore, our variable term must be 7x, and our constant must be 4. And we have created an equation with variables on both sides, variables on both sides that is an identity or has infinite solutions. All right, so they're asking us to do it again. They want infinite solutions, so this side has to be equal to this side. So let's get rid of these parentheses. Negative 2 times x is negative 2x, and negative 2 times positive 5 is negative 10. Simplifying, 4x minus 2x is 2x minus 10. Therefore, these terms must be 2x minus 10. It has to be identical to the left-hand side. Now we're going to create an equation with no solution. And I will tell you that there is more than one answer, okay? All you have to do is create an equation that has an equal variable term, but not equal constants, okay? Well, let's simplify this. 3 times 2x is 6x. And 3 times positive 4 is positive 12, all right? Well, 6x minus 1x is 5x plus 12. So we know that we have to have 5x. We have to have the variable terms must match, but the other numbers must not, okay? They used 8. Any number will work here except 12. 12 is the one number you can't use. You can use any other number you can think of, your favorite number, your dog's birthday. It doesn't matter. You can pick any number you want, but don't pick 12. You pick 12, it has infinite solutions. Any number other than 12, even 11.99 would still no solution. Okay. Complete the equation with values that will result in an equation with no solution. Okay. On the left-hand side, we need to do some simplification here. We have got 3 variable terms. Holy cow. Negative 3 plus 8 is 5, and 5 minus 1 is 4. So this is 4x minus 6. On the right-hand side, we need this to be 4, but this number can be any number in the world except 6. All right? So we can make it 7. No solution. The right-hand side is always going to be 1 less than the left-hand side. Right? This page, you know what? With the COVID and the remote learning, they've told us to streamline our teaching so that we can cover as much material as possible this year. So my version of streamlining is not doing this. Write down that W though. Okay, I do like this one. Olivia and Harry are analyzing the expressions 1/4 times 8 plus 3x plus 5 and blah, 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 blah for all values of x. Olivia claims that the value of these expressions is always equal. Harry claims that the value of the first expression is always less than the value of the second one. Which student is correct? Well, we have to check. All right, we go ahead and get rid of the parentheses. Negative 2 times 3/4 is negative 6/4 x, and negative 2 times positive 7 is negative 14, plus 2 1/4 x plus 24. Okay, well, I think I'm going to write this as 1 and 2 negative. This one, I need to remember this is equal to negative 1 2/4 x, because I'm going to try to do math in my head. So that's what that's equal to. All right. So when I'm asking myself, let's see, we'll combine like terms. If I want to combine a negative 1 2/4, oh boy, I'm going to have to use a calculator because that's carrying and borrowing. Oh, I'm not going to try to do that in my head. No way. All right, we'll just play it safe. We're going to add, can't think of a better way to spend a January day than doing math problems. Combine 2 and 1/4 plus or minus, in this case, 1 and 2/4, and it gives me 3/4. So this is positive 3/4 x, and then minus 14 and plus 24 gives us plus 10. So the left-hand side simplifies to that. What about the right-hand side? 1/4 times 8. What is 8 divided by 4? 2. 1/4 of 8 is 2. 1/4 times 3x is, get this, and it's positive, 3/4 x plus 5. All right? So we combine like terms, the 5 and the 2, and we get 3/4 x plus 7. All right. Olivia said that they would always be equal. Clearly, they're not equal. Harry says the value of the first one is always less than the value of the second one. Oh, I have them backwards. This is the first one. This is the first one. I was like, what's he talking about? And this is the second one. I didn't put them in order. Okay, he says the value of the first one is always going to be 3 less than the second one. Harry is right, because this one is only adding 7 and this one is adding 10. So Harry wins. Okay. Well, that brings us to the end of today's video, okay? Stick around, and tomorrow we'll be doing the 3-5 practice problems video. I am so excited. I think I'll just film that one today because I can't wait to get doing these problems. But in the meantime, go ahead on over to McGraw-Hill and complete the secret word assignment with all those letters you collected. All right? Have a good one, boys and girls. I'll see you tomorrow.